Welcome to my YouTube channel. Today we will discuss the classification of soil water. Soil water can be classified on the basis of the availability of water for the plant growth or the presence of water in the soil. So, if we are talking about the presence of water in the soil, then it is classified on the basis of physical presence of the water in the soil. So, either it is physical classification or it may be a biological classification. So this biological classification indicate the presence of water in the soil which is important for the plant growth, which is available for the plant growth. So, if we are talking about the classification of the water, then we must know how the water will adhere on the soil particle. So, the water will adhere with the soil particle with a force that is called tension. So, that tension can be measured in two terms, either in ATM, means atmospheric pressure, which is equal to 1036 centimeter of water height, or it may be measured in the terms of bar, which is equal to 1023 centimeter of water height. This ATM can also be measured in terms of mercury height, that is 76.39 centimeter of mercury height. Now, when we are saying the water is held with a tension of, it means the how much force be applied to remove that water from the soil solution or the soil particle. Now, there are two type of pores in the soil. One is macropore, and another is micropore. I hope you must know these two terms, micropores and micropores. But there is one term also that is called mesopores. So this is important for the point of view of cultivation of crop. While these macropores and micropores are the teeny pores or tiny pores whose size is less than 0.06 mm diameter, and macropore whose diameter size is greater than 0.06 mm. So the first one is physical classification of soil water. Physical classification of soil water. It can be classified in three groups. One is hygroscopic water, and second one is capillary water, and third one is gravitational water. Now, we will discuss these three type of water one by one. First one is hygroscopic water. This hygroscopic water held at a tension of 31 atm to 10,000 atm. This water, hygroscopic water, always present in a form of vapor. So this is not actually available for the soil crop production. Why? In case of few microorganisms, this water can be useful, but not for the crop production. So this is actually a vapor form of a water which is not available for plant growth. This one is a capillary, second one is the capillary water. This capillary water held in soil between 0.3 to 31 atm. So this capillary water is actually important for the growth of plant. Constitute field capacity and permanent building point also. We will discuss these 2 points. What is field capacity, what is permanent building point, what is hygroscopic coefficient. We will discuss. This is important for the plant growth. Next one is the gravitational water. This water actually a superfluous water which is flow with the gravitational force, and this water will also not available for the plant growth. After the rain or irrigation, the water generally present in macropores and drain out. This water may leach out the salt and the nutrient which we applied for the crop. So this water actually are harmful for the production point of view. So this gravitational water had at a tension of less than 0.3 atm. So this is the physical classification of water. Next is the biological classification of water. Biological classification of water. So this water again can be divided in 3 types. One is superfluous water, and second one is available water, and the third one is unavailable or non-available water. Again, superfluous water, it can be a gravitational water. This water not available for plant growth and will leach out or drain out after the rain or application of water with the influence of gravitational force. That's why this is called a gravitational water. This is again held the tension of less than 0.3 atm. Next one is the available water. This is important for the production point of view. This water held between the field capacity to permanent wilting point. This water held between field capacity to permanent wilting point. And third one is the non-available water. This is a hygroscopic water. This is hygroscopic water, which is present in the form of vapor. So this non-available water is a hygroscopic water which is not present or available for the crop production. Now come to the available water. There are few terms like field capacity, field capacity. The water held at field capacity, the tension of 0.1 to 0.3 atm. 0.1 to 0.3 atm. After the application of irrigation or rain, generally it is assumed that after the 24 or 48 hours, the micropores will drain out and there is retention of water in micropores, which is nearly 40%, nearly 40% for the plant growth. Okay. Next is the permanent wilting point. The term permanent wilting point was first coined by Briggs and Sands, which indicate the availability of water at a tension of 15 bar or 15 atm. 15 atm. So the water will available at this range between field capacity to permanent wilting point for the crop production. At this point, permanent wilting point, this is the alarming point. At this point, we should apply water for the crop, to the crop for the survival of the crop. If it is not that, then there is a next point that is called ultimate wilting point, which is beyond 15 atm. And at this point, crop will die or plant will die. Crop will not survive. Though we apply water to the plant or to the crop, but the plant will again not recur. So this point, permanent wilting point, is very useful, or we can say this is a point where we have to apply water. तो ये था सॉइल फिजिकल क्लासिफिकेशन ऑफ वाटर. अगले वीडियो में कुछ और इंटरेस्टिंग लेकर के आएंगे. तब तक के लिए धन्यवाद. अगर चैनल आपको यूजफुल लगता है तो आप सब्सक्राइब कीजिए. धन्यवाद.